Hey guys, this is going to be a simple tutorial on Modern CMake, and I might break this up into multiple parts depending on how complex this gets. But I want to keep the first video at least simple and easy to follow. So you can follow along, and all of the information I present here will be available on codevion.github.io, which will look like this when I upload this and push it. And then you can click on CMake tutorial, and then you can follow along with the video. And I'm using a terminal-based presentation software called Patat, which is quite nice, and it's able to render my markdown file as a presentation, which is useful for these kinds of videos. So let's get started. Now, our starting point is a simple C++ file, and all it does is prints out hello world to the screen. And you can see that it's the only file in this folder, and if you were to use G++ to compile it, you can do -o some output called hello and main.cpp, and it compiles to a hello binary that you can then just run with hello. Let's see how we would do this using CMake now. So you can see that we have to create a CMakelist.txt file, and then this is a basic setup to get us started. So let's go ahead and do that. So create a CMakelist.txt file, and we will simply just copy and paste this. And now to run CMake, you must have CMake installed on your system, and I was able to install it using sudo pacman-s CMake on an Arch-based system. You can check the version of CMake that you have by using CMake-version, and you can see that I have 3.19 installed. Now, let's go through this file a little bit. So the first line of this is the minimum CMake version required. Now, since this video is going to focus on some of the more modern features of CMake, we're going to use a pretty high version here, and so this makes it so that this program cannot be run with a CMake version lower than this. We set up some C++ 17 related stuff so that we can use more modern versions of C++ as well. And then we give our project a name, and we give it a version, and then all we're doing is creating an executable called hello, which uses the main.cpp file. Now, to run CMake from the command line, all you have to do is specify the directory that the CMakelist.txt file is in, and then it'll generate a make file for you, and the make file is going to be used to actually build your program. Now, you might ask how this is simpler or better than the G++ version, and the answer is as programs get more complicated, and we'll see it happen later on in the video, CMake will abstract away a lot of the complexity around generating your make files. So think of it as a generator for make files, and then you can run make to build your files, and then you can run them. So let's take a look at how that happens. So I can use CMake dot to run CMake in the current directory, and let's remove our existing binary first, so we know this is CMake responsible for building it. So I can do CMake dot, and this, you can see that it generates a bunch of CMake related artifacts and a make file. We can simply run make to build it, and we can run /hello, and it works perfectly fine. And since we used C++ 17, we can actually use more modern features like std optional. Alright, so now we're able to build a single source file and generate our make file and use our make file to build our binary. But I don't really like all of these CMake files cluttering up my source directory. So one thing I usually do is create a build folder, and what I do is, let's get rid of these. Alright, so now I just have my source file, my CMakelist.txt file, and a build directory. Now I can build from the build directory by calling CMake // because I want to build the directory above it, and this will do the same CMake file generation, and then we can actually use make here, and we can actually just run hello again. Alright, and you can see that our main source directory is now uncluttered. All the build artifacts are in the build directory. Now, I won't be going into the terminal and running CMake every time. I do use a Vim plugin that I mentioned in my COC video here on setting up Vim, NeoVim for C++ as an IDE, and include a CMake file. You can see the video linked below, and I will be using that. And let me show you guys how that works really quickly. So if I'm in main.cpp, I can just do /cg to generate my CMake file, /cb to build it, and then I actually just run it using build/hello. All right. That is what I'll be using to build and run my CMake files going forward in this tutorial. Actually, you'll notice that the CMake Vim plugin that I use actually puts everything in the debug folder. So it creates a debug folder instead of a build folder. So I can just get rid of the build folder here. And the compile underscore commands.json is used by COC to give me auto-completion and other cool stuff. So I can do include, iostream, and all that good stuff. And it'll be used later on, and it's well integrated with CMake, and it'll be used to provide me with an IDE-like experience. If you guys want to check out more about that, check out the C++ video. Back to CMake now. So we have a source file, we have a cmake.list.txt file, and let's say we want to add a header file now. So let's take a look at this. So in order to include a header file, you don't actually explicitly include header files themselves, you actually include a directory that contains your header files. So we can do target include directories, we can link our target in this case, which is hello, and the purpose of public is to specify the scope of the stuff that you're adding to your target. So for include directories, you can make it public, private, or interface. And this is more relevant later on when we actually build up a library in CMake, because you want to make sure that targets outside of your library should have access to the include directories that are relevant for your library. And we say that our header files are going to be in our current source directory /include. And this is a common behavior in C++ programs to put your header files inside a special include directory. So we'll go ahead and do the same thing here. So we'll create an include directory, and in include, let's actually create a header file called blah.h, right? So we'll say pragma once, and this is just good C++ practices. And we will create a class here called blah. And inside the class, we will declare a function called foo. And all it does is, mainline this, all it does is it does std cout foo, or let's just call it foo actually. Right, and it doesn't know what std is, cout is, so we will include the iostream header. Alright, and we have to end this class with a semicolon. Cool. So this is our simple class, and in our main.cpp we will instantiate blah, and we'll call foo here. And now I wanted to include the blah.h directories, the blah.h file, so I can just do blah.h. Okay, so as it is right now, because our CMake does not know how to compile this, so right now if we try to compile this, actually, you'll see that we get an error. So in generating CMake files, this works, but in building, it'll give us an error because it doesn't really know where blah.h is or how to include this. So in order to do this, we edit our CMake list.txt file, and like we said, we'll just say target include directories, and we'll just include the include directory from the current source directory. The target starts with your project, and you are adding an executable, and then you're also adding include directories. So once we build it again, this time it builds successfully for us, and now we can do build. Actually, this actually puts it in the debug folder. So debug/hello, and you can see that it also prints out boo in addition to hello world. And one cool thing you'll notice is if I open up my main.cpp file, this should actually, let's reopen it. All right, yes, so you'll notice that CMake also helps generate the compile.json, the compile_commands.json, so I can actually use COC to navigate and get rid of the errors as well. Now we know how to include files. So now any more files that we add in the include directory, we can just use them in our program. Okay, but then the next thing is, what if we have more source files? Now, the traditional way to add more source files in CMake is to add more stuff here. So we have main.cpp, maybe we have a blah.cpp, and then you just keep adding these files. And now, here's where there's a little bit of controversy in terms of what's good practices and what's not good practices. Now, CMake source explicitly discourages this, but what we can do is we can do a recursive search for all source.cpp files in a directory and include them in our executable. Now, why they discourage this is because of CMake is not really supposed to be your build system, but it's supposed to be a small part of your build system. But for most people who use C++ and who just want to get things done, I think this is a perfectly fine way to do things. So what we're going to do here is we're going to actually put our source files in a separate source directory, and we're just going to do a recursive glob for all .cpp files in there, and then we're going to add them to our executable. So let's see how that works. So first off, we need to create a source directory. So let's do src. And inside our source directory, what we're going to do is we're going to put the implementation for blah.h, for our class blah, into the source file. So let's split from actually include and blah.h, and let's do, okay, I want to include blah.h here, and I want to define the implementation for this class in my source file. So what I'm going to do is I'm just going to copy this, paste it. We don't need inline anymore. We just need to do blah, and we can just run it. And here I can get rid of the inline word, and now I'm just doing a declaration in the header file, and I'm doing a definition in the source file. Okay, and I can actually even move the IO stream here just because the header file doesn't really need to know about IO stream. Okay, cool. So we have a header file and we have a source file. But if we try to build it now, so by itself, if I do /cg, it'll build, the CMake will build, and then if I do /cb, it'll actually fail because it can't find the definition of blah.boo, because it doesn't really know where the source file is for this header file, and so it can't really link the implementation of the method that we've declared. So in order to fix this, we have to tell it where to find the source files for blah.h. Now, one way I can do this is if I can just do src/blah.cpp, and if I generate my C++ files, now this works. All right, and now what we want to do is we want to use a recursive glob now. So let's do that. Let's just copy these. Actually, let's just copy the glob stuff. And what we're going to do is we're going to paste it here. And what this does is it globs through recursively all the C++ files in the source directory, and it puts them in this variable src_files that we can then use in our add_executable. So you can just do src_files, and we'll leave our main.cpp file outside of our source files. It's just, that's fine. Or we could put it in our src folder. It doesn't really matter. So if we generate and build, and our target is built, so we can just run it now. Cool. All right, let's talk about creating a custom library now. As projects get very large, we often have to split it up into libraries and reusable smaller components, and libraries are a perfect way to do that. So we can create a library by using add_library instead of the add_executable. Then we specify the name, we specify whether or not we want it to be statically linked or dynamically linked, and then we provide the source files, similar to add_executable. So let's do that for our library, and let's actually make a library for our blah class that we were working on. So I've moved the blah class into a blah directory where I have blah.cpp and an include folder which has blah.h. So we can say we'll create a library blah. It will be a static library, and the location will be blah.cpp here. And for the include directory, I am going to say that the include directory for blah is, and I want it to have public scope, and I'm going to say we make a current source directory /blah/include. And now I don't have to worry about any source files because my hello executable now just has the main file, main.cpp, and it doesn't even have any include directories, so all we have to do is now link this library with our executable. So in order to do that, we just use target_link_libraries. So let's do that. Hello public. And in our case, it'll be just blah. Cool. So let's generate our CMake files and let's build it. And this time when we build it, which is run the make file, you can see that it generates a libblah.h, and then it generates a binary hello. And if we now run /debug hello, this continues to work. Now note that because we linked the include directory to the blah target, when we link that library back to the hello executable, main is able to understand where blah.h is because it's part of the library that we've linked to our target. Now one cool thing we can do is we can have blah folder have its own CMake list.txt file. So let's create a CMake list.txt file inside blah. And let's compare, and all we have to do is we can just take this blah related stuff here, we can put it here. Now the references to the directories can be relative to the current path, and all we have to do is we can just do add_subdirectory. And this ensures that when we add the subdirectory, it'll include the library and we can now use it. And we don't have to worry about creating another project or anything like that. And let's do that. You can see CMake files are built and it continues to work perfectly fine. So let's talk about depending on an external library. Now, some external libraries do have some sort of CMake configuration, in which case you can use a find package which will fill out some certain variables that you can then use to link to your library, that you can use to set up include directories, so you don't have to worry about setting those explicitly. And that's one of the benefits of find_package, in addition to also being able to specify a version requirement, specifying required, and even specify subcomponents like we can with the SFML, which is a media library and has components for networking, audio, graphics, Windows systems. So we can specify these when we actually find the package, and then we can, after that, we can include it using the SFML_include_ directory, which is a variable that the find_package fills out, and we can link to the libraries. And in certain cases, like if we want to, we will also need the dependencies of the library to be able to link to them. In this video, I'm just going to talk about just installing the library in your system, but in later videos, I will talk about how to create a custom find something CMake file or a custom XXX config file for your library so that it can be included a lot easier in CMake. And we'll talk about CPM later as well, which is a really nice way of hassle-free CMake library dependency management. But for now, you can install something like I can install with Yay on an Archbase system SFML or zlib or any other external library that I want, and then all I have to do is run find package. So let's do that. So I do Yay, and it gets installed. And after it's installed, I can basically open up my CMake list.txt file. I can copy this, paste it, and I can now link to I can add the include directories for it, and in my link libraries I can include the library and its dependencies. So you can see our CMake build files builds and our hello executable builds as well. So if we now, let's open up our main.cpp file, let's include something like sfml/system.hpp. And then I can use something like sf in 32 blah, and I can build it, and it builds just fine. So we've seen how we can use find_package to link to a library and then depend on its libraries and include directories automatically using the variables that the find_package sets, or actually the define something.cmake or the xxconfig.cmake sets. And we'll talk more in detail about how this works in later videos, but for now, let's move on to how to explicitly include a library where you know the path for it and it doesn't maybe even have any sort of CMake configuration. Now let's talk about depending on an external library manually, and this is like in case it doesn't have any sort of CMake configuration, or if you just can't figure that out. This is the most straightforward way, it's the most explicit way, and you can literally specify direct paths to the exact library file and link to it, basically. So the first thing you can do is you can try find library, and this will look through your system default library directories like userlib, and you can specify a name for the library and give it a variable. And it's always nice to give it a variable, and find library will actually tell you whether or not the library was found, and then you can just link to it like regular with target link libraries. And now let's suppose it's in a custom path, right? So you can just do find library and you can provide a paths variable, and then you can specify the exact path that you want to link to the library. And then the linking is similar as before. And note that you still need to specify the include directories as well, because finding this library here is just a lib file, and so you also have to include the include directories. And to figure out its dependencies, you have to refer to the library's documentation and other cool stuff. So let's see how we can do this. So I've installed zlib using just sudo pacman-s zlib, and the funny thing about zlib is actually you can check out where it's included. So if I include, you can see there is a zlib.h in my /user/include directory, and in /user_lib, actually the library file for it is just libz.a and .so. So that's zlib. So how do we link to this now? So we can't use find package here. If we try to use find package, let's say zlib, and let's make this required. The funny thing about zlib is you can see that CMake includes a find zlib in its default implementation. So zlib probably isn't the best directory. So, but it does show that sometimes you can install things and have them just be there. But we can see how it would be if we wanted to include it manually instead of using find package. So let's take a look at how we would do that. So we do the same thing. We use find_library, and in order to include the library, let's use the most explicit way possible. So we will do, let's say zlib, and it's just the library file. Now, for all the library files in Unix, they're like prefixed wide, like libz, but you don't want to explicitly say libz, so you can just say z. You remove the sort of lib part behind it. So if I use this, you can see that it actually does find it. And just to make sure, if I just type libz, it won't actually find it. So, and if I go back to just z, it will find it just fine. Cool. So, but let's say I want to make it even more explicit. So I can just do paths, and I can specify /user lib libz.a. Yeah, so if I wanted to be very, very explicit about the exact file name, I can say find underscore library, and I'm going to put it in zlib. It would be libz.a, and like this is the exact file name, but by default it won't actually look for it. And then I'll just say required, and I'll say pat, and I'll actually just specify the exact file name. And then I am able to just link to it by just adding clib here to my target link libraries. Now, that still doesn't mean the include will work, so I will probably have to do so I probably have to just do, let's see if I can just do include zlib.h. Yeah, actually, so by default it will include, CMake does include the system like user include directories, so we actually don't have to worry about system install libraries having to comply with having to explicitly include stuff there. So, but if it wasn't, let's say it wasn't, we want to set the include directory as well. So set, in our case it will be zlib include dir, and it would be something like /user /include. And that's it. I mean, in our case it is in the system default directory, which is already included, but and then you would add it to the include directories here, and you would say something like zlib _include directory. And that's basically it for this introduction video. This has gotten a bit longer than I anticipated, and I want to dive into some of the more deeper, more complex systems on how this grows. I want to talk about how to use Google Test with CMake, and that'll be in a second video. And one final thing I want to talk about is CPM and how nice this is. So you'll notice that even in like find underscore package use cases, you still have to worry about the variables, and that's really messy. With CPM, all you have to do is you have to once include cpm.cmake, and then afterwards any package that's ready for CPM, all you have to do is add this little blurb here, and then you can just link to the directory. You don't have to worry about include directories, you don't have to worry about the library files or anything else. And they have a few examples here for some sample libraries that follows convention. And you can see that it actually pulls it directly from GitHub as well. So this is super nice. I'll dive into CPM in a later video as well, but I just want to mention it because it uses some of the nicer modern features of CMake. So anyways, thank you guys for watching. Please like and subscribe.